Hello everyone. Today we will calculate drag coefficient and drag force for a fuselage body. So here is the body of a fuselage. I've just modeled, and we will perform a computation fluid dynamics or CFD to determine a drag force, and then we will calculate a drag coefficient. And actually after that we will use MATLAB to make a to actually make a chart between drag force and velocity. So I'm here doing a external CFD in SOLIDWORKS flow simulation. So I'll use air as a medium, laminar and turbulent both. So as you can see, the body is aligned in Z direction. So I'll be applying a velocity of the air in Z direction, which is around 30 meter per second. So yeah, so here is 30 meter per second in Z direction. And finish. Next, I'll be editing the computational domain. Okay, and adjust it accordingly. Moreover, I will assign some goals. So we will need a force. So actually, we are here to calculate calculate drag force in the axis of z. So we we actually check on the we check on force of z force, and name it as drag force. So here is the formula for actually calculating drag coefficient. It's CD2 into FD rho velocity square A. So here is so actually here is FD is drag force, rho is density of air, and U square is the velocity, and air is a frontal area. I'll explain later what is the frontal area. So we will also be adding actually equation driven goals, equation driven goal, and in where we will be putting these drag equations. So as you can, the drag coefficient is of 2 times drag divided by density, or the density of the medium, multiplied by velocity square multiplied by frontal area. So this is drag coefficient. So I'll start with brackets. 2 times the drag force, which will be calculated by CFD. Next will be So I'll just write it down so it is easy to explain, so you can understand it easily. So CD, which is drag coefficient, is equal to 2 times the drag force divided by rho, which is the density, multiplied by the velocity square. Velocity. So we will be using this CD or drag coefficient uh, to actually plot a chart between drag force and velocity, and to see the changes. So so actually to actually plot this graph, I'm using MATLAB here. So you can see that in this report there are reports that drag force is around 0.076 Newton, and the drag coefficient, which is unitless, but it is showing it in Newton, but in actual it is unitless, so it's 0.007. So I will be using this value of 0.007 in this MATLAB program, which will plot a graph between drag force and velocity. So rho is 1.22, CD is 0.007. 0.007, and the area is 0.02, the frontal area, calculated by SOLIDWORKS. So the velocity 0 to 70 means the actually velocity ranges from 0 to 70. We are calculating a drag force in multiple velocities from 0 to 70, and we will plot a graph for it. Yeah, velocity ranges from 0 to 70 in meter per second. So I will just run this program. This is the drag force, and we will plot run. So this is the chart. So here you can see the value for 30 meter per second is around 10. So you can actually you will see multiple values from 0 to 70, and here is the graph plotted. So I'm adding x label and y label, so you can see the graph clearly. So this is velocity, and this is drag force at 0.007 CD. CD of 0.007. So this is the graph. So you can also